Hi everyone. So, how are we all doing today? I hope everyone is out there and enjoying. Well, we're having lovely weather. I hope you are all out there and enjoying the weather too. If you've got good weather, that is. So, it's been nearly 2 months since we've done a live stream, and we have a sort of a new face to some of you. We've got Kieran Gill. Kieran is in the same team as me. So again, Kieran's normally on the back of these live streams helping us do all the work for them. But we've got him actually to come in on this one. So yeah, so Kieran, do you want to say hello to all the
Hello,
brilliant
everybody.
people?
Good afternoon, good evening, and good morning for everyone around the world. So, thanks for joining, first of all, and we're gonna take a deep dive today into showing you how you can use machine simulation to get the most out of the toolpaths that you're programming. And so, I'll walk you through really the basics of how to use machine simulation, and then as well as what happens in the event that you don't have a machine. What can you do if you look through the Autodesk online library and hey, heck, I can't find my machine. So I'll walk you through some of that as well. We'll set up a machine right from scratch, so you kind of have a really good idea, so once you've finished the live stream, you can actually walk away and say, actually, I'm going to give machine simulation and machine builder a bash. And a lot of the one thing to bear in mind is a lot of the OEMs, for example, Haas is a really good example here. They put a lot of their machines, if not all of their machines, online in 3D format. So you can literally download one of their machine models and import it into Fusion and follow the same process that I'm going to be doing today on screen. And hopefully you'll end up with a similar result and a working model you can use to start simulating some of your toolpaths.
Brilliant. Thanks.
Okay.
Thanks, Kieran.
Okay.
Just before we start, everyone, again, I'm rusty at this, so I hope you are as well, so you can come along with us. I want to know, where are you all from, and what have you done this week with Fusion? So what have you done? What have you made? What have you designed? I want to hear some people say they've tried Machine Builder and Machine Sim and loved it. So again, everyone, come on. These live streams are as much about you talking to us as us talking to you. So before we let Kieran go, again, don't forget, where are you from? I love to see where our users are based from. And what have you been doing with Fusion? That's sort of the most important thing I always like to see. Sometimes we get some really nice topics and it gives us a couple of ideas of what we can do on future live streams as well. My internet is not the best today, so if we end up skipping anything, please let me know in the chat and we'll work around the issues. But let us know if there are any issues and we'll do what we can to solve them. So without any further ado, Kieran, the floor is all yours.
Thank you very much. Okay, so can everyone see my screen? I'm just going to wait for a couple of comments in the bottom just to make sure everyone can see my screen okay and hear me okay.
Yeah, everyone's good, mate. Everyone's good.
Oh, so what you're seeing on screen is a model with a steep and shallow strategy on there. Now, typically with machine simulation, you've got two types of methods that you can access machine simulation. So we're going to take machine builder, we're going to put a divider in between at the moment. We're just going to shift machine builder to the side for now. And we're just going to look at machine simulation and how to access it. Okay, so there's two typical ways you can go about accessing it. And the first way really is to click on your setup, right click, edit, and what you'll see appear is this machine tab. Now, this has been in the product for quite some time. However, the infrastructure behind there has kind of been, developed over a number of months. So I'm going to take you through that now. So the first way we access it is simply hitting the select button and up pops this dialog. Now, this kind of looks like a bit of an intimidating dialog to begin with, but I'll just go through it just to give you a bit of context. So you have recents. Generally, what happens is, depending on the number of models you use, the machines that we used in those models and more projects will all feature in this recent folder. The document really contains only the machines used for this particular document, kind of self-explanatory. Now, when we look at machines, this takes a snapshot look at all of the machines you've got saved locally. There's a linked folder which allows you to, if you're not using a team hub or you're using a single user storage, you can right click on this and link a folder to, for example, your desktop, where you have your machine models downloaded to. And when you click on that link, it'll refer back to the location on the desktop, and the machines will be populated in your library. So you can currently see I don't have any machines. Now, the important bit is Fusion 360 now ships quite a lot of machines as standard as part of its online library, and gives everyone access to this library. Now, you're probably thinking, how do I access the machine library? So I'm just going to quickly cancel here, cancel my setup, and go to my Preferences tab. And I want to show you the two settings you need to activate to get access to Machine Builder and Machine Simulation. So you'll see there's the preview features at the bottom. You click on that, and if you type in machine, you should see Machine Builder and Machine Simulation. So I want you to check those two options. Okay, so let's jump straight back in. So we've edited our setup and we've opened up the machine dialog. Now, where I left off was talking about the Fusion 360 library. Now I'm going to click on that and I'm going to expand the list. And there's a number of different machines that Autodesk is shipping out as standard. Okay, now what we are really looking for is the machine simulation ready files. Now you'll see this little filter on the right-hand side. The thing I do is I simply check that box, and I'm now getting a list really of all of the machines which are simulation ready. Now, what you're seeing is you'll see this little sort of 3D view cube, if you will. And this little view cube actually denotes that a particular machine simulation file is simulation ready. And what does that mean? What does it mean to have one of those icons? Well, it means the file itself needs to have two things. It needs to first have a valid machine kinematics file associated to it. And second of all, it needs to have a 3D model associated. Okay, when those two items are met, or criteria are met, there's a little icon which denotes the machine is machine simulation ready. Okay, so in this case, I've kind of located my machine. I'm really keen to have this UMC 750, so I go ahead and select it. So what's going to happen now is it's going to go ahead and download the model from the internet and the Autodesk website, and it's going to ask us, where do we want to store this? Now, a little trick here. Let's have a look at the location here where I want to store this, and have a look at my location in the top left-hand corner. So I've got home, sync up data, and test. Now, the important question that a lot of people have been asking is, can I go ahead and, for example, save my machine in a different project? Absolutely. So in a situation where you have a team hub, you can go ahead and save a machine in a different hub so that it can be shared with different teams or different users who are using that particular machine or want to use that particular machine. So really powerful that you can save it across multiple projects or in different locations. Okay, so as part of that sort of download and upload process that you just saw, it's also XREF'd the part or the machine into our setup. And you can see that there at the bottom, it's referenced as UMC 750. Now, the first thing we're going to have a look at is, as part of bringing that model in, you now get this kind of extra tab on top called part position. So clicking on that allows us to now see how the part is silhouetted on the machine. So the first thing to bear in mind is that what we try to do as default with positioning models inside of the machine is basically take the lowest point of a bounding box around everything that was set up, everything that was highlighted in the setup. So you can see on the screen here that this model, for example, has got the lowest point here at the bottom of the model. Now, it's quite convenient that it's there at the moment, and we give you a number of different options that you can play around with to fine-tune the position of the model in the machine. So a lot of you are familiar with this, so very similar to the way we define our stock in the traditional way in the setup. So you've got selected point, model box, fixture, and stock box point, but I'm going to leave mine on box point. Now I can go ahead and pick a point I want to snap to the table attach point, but I'm just going to go ahead again and pick that middle point. Now, the next one along, and interestingly, notice how the machine is silhouetted out, and that's purely to denote that we're defining a point on the model rather than the machine. The next step is really to define where that model attach point attaches to the table. So now I can go ahead and say, well, actually, I don't want it on the sensor. I want it at the end of this bit of 2D geometry. So I can click that and it shifts. I can go and select a point if I really wanted to. I can go and select the center of this line if I really wanted to. And you also have, if we go back to this fixture point for just a second, we've given you a number of different drag handles as well to go and pull and drag the part around. Now, what you will see is that we haven't included a rotational component. And that is purely because we are strictly aligning the axes of the part to the axes of the machine. So therefore, we haven't provided a rotational component. And really the reason behind this is because currently we're not supporting the ability for users to start with their A or their B axis at -90 or positive 90 degrees. So hence why we don't have that rotational component. Okay, so once we're happy with the position of the part, we can click on OK. And the part is positioned in our machine. So I'm just going to zoom out a little bit and we can kind of see the machine in the background, all kind of laid bare, imported in as an XREF. Now, what we'll do is I just want to jump back to the home in my data panel, and I want to show you that that machine has been brought in. You can see the Haas UMC 750. So you get an idea that it's actually downloading a full F3D model into that separate location. So just something to note there. So let's just jump back into our test folder. Great. So again, what's the easiest way to access the machine builder functionality is to basically just right click and hit simulate. So we'll just give that a couple of seconds. Again, what it's going to do is it's going to bring in that XREF again, and it's going to try and simulate the model for us or simulate the toolbar for us. So whilst we're waiting for that to load, Richard, what's happening in the chat? Any questions?
No questions at the moment, but people are very interested in machine simulation. We've got Liebherr CNC's made his own machine, and he's using this to simulate that. So that's really interesting.
Excellent.
Yeah, it's a really nice thing that if people are making their machines in Fusion, we can start actually joining everything together. We haven't got to have certain things done in one and then bringing them over. We've got Anton's got a Haas TM2P, so hopefully he's going to be making use of this as well. So yeah, people really enjoying this. And I do want to stress once again, people, that this is currently in preview, so you have to activate it. If you don't see it there, you have to activate it. And for those of you that don't know how sort of we work in Fusion with previews, our idea is to try and show you, as soon as we have something we feel is good enough to show you, we want to get your feedback. We want to see what you've got over here, and you can help us do things. So this live stream is much about us saying things that maybe aren't in there as what things that are in there as well. So please, we really appreciate good constructive feedback on what do you think is missing, and we are the people that you need to be passing that on to, and then we'll make sure that gets passed through the chain. So back over to you, Kieran.
Great, thanks very much. So simulation's loaded. So I'm just going to hit the play button, and automatically I'm just going to zoom out a little bit as well. We can kind of see the machine movements on the machine, and I'm going to go ahead and just turn off the cutting moves there, so we can kind of see the machine moving, and kind of speed it up a bit so we can see the machine moving. Some multi-axis movements happening there as well. So yeah, really nice. And the beauty of all of this is I can go and turn off the base as well, especially where I've got accessibility issues. So so some trunnions are not mounted in this particular way. They're mounted in either a positive or negative 90, which means that when they do flip to the positive aspect, the actual bottom of the table is facing you as the viewer. So this allows you to turn off the base, navigate around, and actually see the bits that are machining around the back of the machine. So really, really, really good. It's also important at this point to talk about some of the limitations of machine sim currently. So what is not currently supported? And what is not currently supported is the ability to component check against the different components on the machine. So for example, nothing is stopping the head at the moment plunging into the table. The simulation at the moment on public preview it's purely an animation tool in many ways. And currently there's also no support for things like Go Home G53, Z0, There's no support for linking moves between toolpaths. So when you do go between toolpaths, you'll kind of just see it automatically start the next toolpath. There's also no support for things like cutter compensation on 2D contour, for example. So if you did select cutter compensation in your 2D contour, for example, it would throw you an error and just force you to do normal simulation without the machine. Okay, so those are a couple of caveats to be aware of currently with machine simulation. But it does really give you a nice idea of the simulation of the toolpath. Okay, so let's jump out of that for a second. And I really kind of, at this point, want to focus on some of the intricacies of what you're getting when you download one of these machines from the online library. So, and the only way I'm probably best going to describe this is if I go to the setup button and let's go ahead and select the steep and shallow strategy. And what you're going to see straight off the bat is that the post that is associated to this machine when you download it is a machine simulation post, which has been specially designed by the post team to work pretty much with any type of machine that you build or that we have in the Fusion 360 online library. Now, the important bit here is that there's this checkbox now which says use machine configuration. Now, this is really important because what's happening inside of this machine simulation post is that we've stripped out all of the machine kinematics and moved them into a separate machine configuration dialog, which you'll see later in the machine builder. Okay, so the important bit here to realize is that if you have a post, whatever is defined in the machine kinematics, the post actually consumes those kinematics and then posts out the code, not only as NC code, but posts to the simulation as well. So the beauty there is that whatever you're seeing in simulation is first being interpreted by the post before it goes to simulation. So you're getting basically posted code running in the simulation. So we found that that is the most accurate way to do it. And that's how we've done it going forward. Okay, so let's go ahead and post this out. And what it's going to say is, do you want to overwrite this? And let's just quickly have a look at that code. We'll just wait for that to post out.
Well, that's posting, Kieran. Am I correct in saying that this doesn't support probing because the probing uses CAN cycles?
Correct. Absolutely. So that's also correct. Probing currently not supported as well in simulation, but like with all of these things, when we go to release, we're going to look to support things obviously like collision detection, like for example supporting probing functionalities on the CAN cycles, like for example supporting the linking moves between different toolpaths and for example G53Z0s, as I mentioned earlier. So those are all things we're looking to support when it does come out of public preview.
Definitely.
Okay.
Brilliant.
Yeah, go ahead. Sorry.
I'm saying, brilliant question, Gabriel, about the probing. People, please ask us your questions now. You've got us here. Use us. We want to be as open and honest about what you can do, what you can't do, and how you can do that. So please keep the questions coming. It makes it so much nicer for us to be able to answer your questions for a bit. Oh, one more question just come in. What was done to... I'll leave that basically saying, what do you do to hide the base? But I'm sure you'll show that how you define the base later. So Lee, Kieran will show you how to define the base, and then it was the base that he said hide. But you'll see that in a minute.
Cool. Right. So we've posted out using that machine simulation post. Now, interestingly, it's given me no NC code. So this is really important because as a public preview, we do not want people to use this machine simulation post as output code to run on the machine, purely for the fact that the machine kinematics will change the output. So for example, if they've been using, for example, the HAS post they've been using for the last 4 years, and then they transition to a post which has got machine simulation and special kinematics defined inside of Fusion 360, their outputs will be very different. So for the public preview that you all have access to at the moment, we are not allowing using this sample post to output code. And I'll bear with me just a second while I explain. So what we've done as part of the output is we've also put together a number of articles. So I'm going to go ahead and open this up for us. So hopefully that will load up. And what you'll see is a Autodesk knowledge network article, which was created by George Roberts and myself. And basically in this article, we're going to explain why the simulation post-processor exists, why we've included it, but also gives users a link to where they can go and modify their own post-processors to make it machine simulation. Because what you need to understand about all of your posts, if you want to use your post for machine simulation, it needs to be made machine sim ready. And the only way to do that is to follow a guide that we've put together here. And I'm sure we could put together I don't know if I could send Richard
I'm putting it in the chat now.
The links to that. Do you want me to quickly highlight that and drop that?
It's fine. I've already got it. It's going in the chat now.
Brilliant. Okay, great. So there's the first one. And then the second one, the original document, kind of just highlights the reasons why we included the simulation post processor with all of our machine simulation files. Okay, so basically we want people to understand what they are doing before they run it on their machine. So this was the best way we thought of this working. Okay, so I'm going to close that down for now. And let's go back to our Fusion 360 library. Now, if we open up that same NC program, you're probably thinking, well, how do we get code out of the simulation? The first thing you can do is once you've decided that you know what you're doing, you're happy to run on the machine, you can then go and select a post from the library. Now, what the post-processor team done, they've done an amazing job here, is they've gone and updated a lot using this machine simulation check button. They've updated a lot of the online generic posts you get on the HSM Posts website to support machine simulation. So now you'll see, there's Haas, Fanuc, Siemens, Tormac, Mazak, Herco, all of these now support machine simulation. So for example, if I wanted to at this point go and select the Haas next generation controller, I'm just going to go ahead and turn these off because I don't want it to override my machine kinematics. And if I go ahead now and say, let's go ahead and post this, let's overwrite that file, and we'll just wait for that to appear in the bottom right-hand corner. So just bear with us while that happens. So because we've just seen that code being populated in the bottom right, I'm going to open that code up, and there you have the posted out code just by using one of the generic machines, generic post processors from the online Fusion 360 library. So once you've tried the machine sim, you're happy with it, you know what you're doing, and you want to post it using one of the generic posts to get code out, there you go. You can use one of the online generic posts because they've been updated to support machine simulation. If you don't want to do this and you have a custom-based post, well, you have a couple of options. Either you follow the guide that Richard put the link to in the chat window, or you go to the Autodesk Services Marketplace to find someone who can help with modifying your post. So those are the options you've got, and I think it really covers all of the scenarios we think people are gonna potentially need. And yeah, we thought this is the best way to let people know about the post situation. Cool, great. So that's what I wanted to show on machine simulation. Now, before we actually move on, I actually haven't shown the second route, how to get machine simulation working. So we showed the first route, which really is right click on here, edit, and go into your machine setup. Okay, the second route is literally, now you'll see as my cursor moves to the top here, there's this machine library button. So I'm simply going to hit the machine library button, and it opens up that same dialog where we go to select our machine. I'm going to open up again, select simulation ready machines. And again, here I can go ahead, for example, and pick a Autodesk generic machine. Now, what Autodesk has done is kind of also given you a lot of basic machines. So 3, 4, and 5 axis machines, all of different combinations, head, table, head table machines, so that if you don't have a machine that you're going to be using on, at least you can simulate it on a machine that you think it will be going on. So as we scroll down, you can see all the different 4, 5, 3 axis machines before you actually get onto some of the others. So really, really nice. The post team have done a great job in creating these Autodesk branded versions. Okay, so once you've got the machine you want, you can simply click, hold, and drag it into your library, into your local folder. Again, it'll download and ask you, where do you want to save it? Again, I'll save it into the same location as I did for my Haas UMC 750. And you'll see in the sort of bottom left-hand corner, it's kind of downloading it and going to then re-upload it again. Okay, so there you can see that happening. Okie dokie. So those are the two methods. And then, for example, if I did want to use this machine that I've just got, I can just right click and say edit, go to my machine selection, and in the local folder, there you can see the machine we've just downloaded, the Autodesk generic 3-axis machine. You can go ahead and select that. Okay. So that's basically how you use and access machine simulations. Hopefully it's nice and straightforward, to be fair. Any questions coming in on the chat, Richard?
We're all good for questions. A lot of people, that article was a brilliant shout. Some people are going to definitely follow that up and see. So I think that's the key thing to say to people is look at the library, go to recent changes and just have a quick look at the last month. And if you see their added support for machine simulation, I just quickly had a look. The Haas Next Gen control was done on the 21st of last month. So just have a quick look and see there if you can see that. If you can see that then you can use the post processor for both making code and for machine simulation. If you don't see that, then use the machine simulation post to simulate, and then the normal post for creating NC code. So that's some really good points.
Again, if you want to just check from within Fusion 360, hit that little icon, go down to the, beg your pardon, if you want to go into your, for example, your NC program, edit that out. Let's go and have a look at the settings. Let's go and change this post out. And from the Fusion 360 library, show me only machine simulation posts that have been updated. And there you get a list of all of the ones which are kind of already on the HSM posts website. You can pick the one which kind of matches your preference.
Perfect. And another one, I just don't want to ignore the question from Heisey Labs. The functionality so far is amazing. Something he's been waiting for years. The important things for themselves is being able to simulate with cutter comp and also collision detection anywhere on the roadmap. What we can say is they are definitely things we see the need for. We can't really comment on any timescales because work always takes a different amount of time when you start it, when you think it will take, but please be aware they are things that we know are needed, and we will work on them in due course, and hopefully we'll be able to provide some more delights in the future. But yeah, your comment is not being ignored, and we are aware of sort of what needs to be done to finish this off.
Yeah, and just picking up on that, we're absolutely committed to not releasing Fusion until we have bare bones, simulation ready, kind of accurate, giving you warnings when there's collisions and near misses and that sort of thing. So yeah, when it comes out of public preview, we don't know when that's going to be, but you can guarantee that there's going to be a certain amount of extra functionality which is going to make your lives a lot easier. With things you've just mentioned, like for example collision detection on components. So
definitely. And one last question, sorry to interrupt you, but one last question that's been answered is this currently an extension? This currently is a public preview. It is also, as of today, it is not deemed for the extension. So our current plan, as of today, is not to put this in the extension. Of course, things can change, but that is not the current plan. So that's what we are at the moment. Hopefully that makes things clear. Everyone with a Fusion 360 license can hopefully access this, but it is a preview, so you need to turn it on.
Yep, and again, if you've got a student license, again, you've got access to machine simulation. So that's an also important thing to realize. And like Richard has said, he said it perfectly. We intend to have machine simulation as part of Fusion base, not part of the extension. Don't know what the packaging will look like going forward, but the intention is that it will be in the base product. Okay, so finish machine sim. Let's jump straight into machine builder. Now, this is an interesting one because a lot of people will download their machines, and I kind of just off the bat want to put out a couple of key things to bear in mind when you start building up your model. So what you need to do is have a look at sort of the left-hand side here of my model tree. I've got the sort of enclosure, I've got the base. And if I open them up, for example, if we look at the Z-axis, we look at the bodies, each of these are independent bodies which have just been dragged into a component. Okay, so that's basically what you need. So a lot of the models, for example, so Haas do a really good job recently. They've updated their models recently to kind of fit this moniker or this kind of layout, if you will, where they've kind of highlighted all of the axes all in one kind of component. But what you may find is everything's just in subcomponents and all over the place. So it's your job really. And then this kind of takes this is the most time consuming part of Machine Builder, is kind of just bundling everything up in the main orthogonal axes. And that's what my, what's the recommendation is to you, is to bundle everything up in A, C, B, X, Y, and Z, depending on the axes you've got. And also you want to kind of take away all of the components which are not movable and bundle them up in the base or the enclosure. Okay, so that's my recommendation for now. When you are modeling this, if you are modeling these machines up on your own and you haven't got a model from somewhere else, the recommendation is that you model all of the axes in their home positions. And the reason for that is because inside of the machine kinematics file, we actually have a home offset value, and currently that is set to 0. So any offset you apply to any of the axes home positions will be an offset of the position it's in. So the recommendation is model your machine in, or model all the axes in their home positions. Okay, so having got that out of the way, how do we jump into the machine builder? So I'm just going to hang on just for a second because there might be comments on this.
No, but I would just say at the moment that's a really key point that Kieran's just made. Don't forget that if your model from your machine tool builder is not in its home, go into the design environment, make sure you move everything around so it's in its home, and then build it. Don't build it until you've got it in its home position. That was a really important point that Kieran said. One question that's come in: is this available with mill turn? Well, sorry, I was like, the mill part of it, if it is a standard sort of, if it's a mill turn, then it's more a milling machine than a turn, so we can simulate the milling proportion of that. If it's a turn mill, it's probably not going to be able to be defined correctly because that will naturally be a lathe configuration with a spindle.
Correct.
So,
100%. Yeah. 100%. Richard nailed it there. I don't need to add any more to that. Perfect. So the way we access the machine builder is you need to actually be in the manufacturing workspace. And once you've done that, you've got, remember those two options, machine builder and machine simulation, need to be checked within your preferences. So once you've done that, you can go to the utilities tab and there you'll see the machine builder functionality. Now, just before we jump into the machine builder, let's just focus on what we're seeing on the screen. Now, the approach always, and this is something people really kind of miss sometimes when they're starting out with machine builders, it's that with the Fusion 360 machine builder, you build from the bottom up. So in this case, what we've got is we've got the base, and then you'll see these kind of 2-axis guide rails here. Now, these axis guardrails allow, and if we just open this up for a second, allow the y-axis to move along them in a y direction, a y positive and a y negative direction. So what we've got is we've got the y-axis, which sits on top of the base. Sitting on top of this y-axis, the x-axis needs to slide or translate along the x positive and x negative axis. Okay, and then, you're starting to get the picture here. What's sitting on top of the x-axis? Well, it's the a-axis. So we can see that a-axis trunnion on top. And then, believe it or not, on top of the trunnion is the c-axis. So that's what we kind of structure we have. And then you've kind of got the z-axis head on its own. So remember the configuration: base, y, x, a, c, and then Z or Z sits on its own on the head. Okay, so let's jump straight into the machine builder. Now, the first thing we're going to do is jump to our local folder, and we're going to hit this little plus icon. And at the moment, as Richard pointed out, only milling is supported at the moment. So we create a milling configuration file. So in this instance, I'm going to give it a nice name like, you know what? Okay. Then what we do is, this is a VF3, and it's certainly not Autodesk that's made this machine. It's Haas, and it's a NGC controller. Okay, so a couple of things here is you can go and put in the dimensions of the machine, the weight of the machine, the capabilities in terms of tooling, the maximum feed rate for the motion of the machine, the working envelope of the workpiece. But these are currently not having an effect on the machine kinematics file as we speak. They will do in the future, but at the moment, they are not taken into consideration for the kinematics. The bit that I really want to focus on today is looking at the kinematics chain. So immediately we get given this XYZ on the table and a spindle at the bottom. The important thing here is we need to build the kinematics in the same way the machine is built on screen. So remember we said we start with the base, then the Y. So again, I'm just going to drag the X, and we're going to start with the Y because the X sits on top of the Y. You can see that sort of building down tree at the bottom. But then we see there's a Z linear, and that's a problem because actually that's on the spindle. So I can click, hold, and drag it over to the spindle, and it drops down. Now, we've got our Y and our X. We're still missing two rotary components, the A and the C. So I can right-click on my table and say Add Rotary Axis. It adds in the rotary A. Now, if yours was a B axis, you could simply hit the B and change it to a B rotary. In this case, it's an A axis. So we just need to add another A axis for the C. And because A has already been chosen, it knows it's going to pick the C axis. Okay, so that's kind of looking correct to me. Start with a Y, X on top, A trunnion on the top, and then a C rotating table on top with the Z or Z located on the spindle. So really happy with that. Now we can go ahead and start defining some of the key ranges of some of these orthogonal axes. So we can give it a specific name or an alias, but really the bit that I want to focus on there, you can see that home positioned at 0, but the bit I really want to focus on here is the range. So for this Y-axis, we're going to go ahead and put in a minus 400 mil range and a positive 400 millimeter range. And for the X-axis, we're going to do the same thing. Here, we're going to use a minus 600 millimeter range and a 600 millimeter range as the max. Now for the A-axis, here we need to be a little bit careful because the orientation vector around which the A-axis rotates is super important to define at this stage. And that's why I said to you earlier on in machine simulation is that whatever is defined in this configuration dialog going forward, if you want to use machine simulation, that affects the output you get when you use machine simulation and a machine simulation ready post. So the post actually consumes these changes and posts out the code. So that's really important. So let's have a look at the A-axis. So the A-axis is really rotating along the X direction. And because it's doing that unit vector, we place a 1 in the X column. Now the C, if we have a look at the C, the table itself, this rotates indefinitely through 360 degrees, and it rotates around the Z axis. Hence why there's a 1 in the Z column. Cool. So we've sorted the orientation. Let's just quickly go back to the axis and define the range. Now the trunnion actually has a limited range of minus 90 degrees and positive 90 degrees. Okay, but also I wanted to have a negative preference on the two options for multi-axis moves. And the reason I'm doing that is because if I chose I'm only specifying negative because I've actually tested this before, is I want the machine to actually swivel its A-axis minus 90 towards the back of the base so I can see what's going on the machine rather than the trunnion actually flipping towards me so I can't see what's going on. So hence I'm choosing a preference one over the other. So that's really important. And then on the C-axis, actually, it's unlimited and spins through 360 degrees, so I don't need to do anything there. Okay, so one of the last things we need to do is just define our z-axis limits. So in this case, we can specify something like -400 and 0. I'm pretty happy with that. And importantly, let's go down to the post-processing area. Now here, what I want to do is I want to pick from my local. I've already got a machine sim ready post, and I can go ahead and click on OK. So what you're seeing now, remember we spoke about this icon on top here. So we need two things to be valid. We need one, a valid machine kinematics file, which we have, but now we need to define the 3D model data and associate that 3D model data to the kinematics file. So we're going to go and select our machine kinematics file we've just created, and let's go over to setting up our machine. So I'm just going to stop there for just a minute, and let's just check on some of the questions, if anything's come through.
Not many questions so far, but lots of comments on how good things are. Yeah, to clear up, this isn't also just for multi-axis. You can use this for a 3-axis machine. You can use it for a 4-axis, 5-axis. It's not restricted to one or the other, so don't worry about that. There was a question about multi-setups. So I'm gonna go for answer this one, and then you're gonna correct me when I get it wrong.
Cool.
So currently with a multi-setup, as long as the physical part hasn't changed, it's going to simulate. But if you've got like the top side of a part, then flip it over, because it's having to like re-reference the part, it won't simulate that. Did I get it right?
Correct. Yeah, absolutely.
Perfect. So that was from. Let me just make sure I call people out properly. I believe that was Daniel, but I've lost it. It's gone up the top now.
Nice, Daniel. Thanks for joining us.
So, yeah, but again, people, please keep these questions coming. It makes things a lot better for us to have some real-life questions on there as well. So thanks, everyone, and back over to you, Kieran.
Cool. So, quick recap. We've defined the machine kinematics file, and we need to now associate that kinematics file to a 3D model. So, I've just unblanked the enclosure and the base. But first of all, we need to sort of start defining the attach points for where the tool's going to attach, as well as where the part's going to attach on the table. So first things first is I'm going to just zoom in here. Now, one thing to bear in mind is you can select geometry. You can select joint origins. So if you go ahead and put a joint origin on here, you can select that as a position as well if you do not have geometry. So that is possible as well, and yeah, that works. So tool, I'm going to select the top here, and you can see it kind of highlighted as the tool position. Zooming out, let's have a look at that table, and actually as part of the table or the part position, I want to locate it in the center of the table. You can pick other bits of geometry if you want to, but I'm locating mine at the center of this table. Okay, so effectively we've done selecting the tool and the part position. Now we go ahead and select the static components. So here you can go ahead and select the enclosure, but I'm going to go ahead and also select the base because it's part of my non-moving components. So I'm going to go ahead and do that. And that's where that question comes in for the base. It's actually going to allow you to blank off that as part of the machine simulation. You can turn off that base when you kind of select it from this particular dialog and the tree, the browser or explorer. Okay, so once they are selected, we can go to the z-axis, and you can kind of see how it automatically kind of grays out the bits that have already been selected, which is really nice. So z-axis selection, let's do the same for the y-axis on the table, x-axis, and then interestingly, when we come to the a-axis, I'm going to select the a-axis, but you'll see on the right-hand side of the a-axis, there's a secondary component selection. And what this is asking us to define is really asking us to define the point around which the a-axis rotates. So I'm going to select that bit of geometry because I know that it swivels around that position on the trunnion. And again, we're going to do the same thing for the c-axis. So the c-axis gets selected. And again, we need a rotational component, and I'm going to pick the base around which the c-axis spins. Okay. So we've defined everything. Let's click on OK. But do we know if we've done it correctly? Fortunately, there is a little jogging button on top here, which allows us to actually simulate jogging some of these axes to see what's going on. So let's kind of drop the z-axis down a bit. We can see that moves okay. Let's start jogging the y-axis back and forth, and that moves okay. Let's jog that forward and then start moving the x-axis along as well, and that moves okay. Then what about the a-axis? So we can start jogging the a-axis. That looks really good. I'm really happy with that. But let's also jog the c-axis as well to make sure that's all running as smooth, and we'll just move the a-axis along, the x-axis along. So that looks really good. I'm really happy with that. So actually what we've done is really good. Really happy with that. So we can go and say finish. And do we want to say yes to saving it? We say yes. What it's going to do in the background, it's going to tie in the machine kinematics file, but it's also going to tie that into the 3D file, and we're going to be good to go. So now once you've exited the machine builder, you can actually hit the old X button there because it's saved. And I've now got this model in front of me. And you can see I've programmed it. I've got a number of operations here for op 10 and op 20 effectively, but I want to go and use that machine I've just created. So I right click again. This is very similar to the way I showed you how to use machine simulation. Hit the edit button, go to the machine, select it, and there you can see our custom milling machine that we've just created, and we can go ahead and select that, and it will allow us to then part position our part in the machine that we've just created and go ahead and simulate that. So, and that is as simple and as easy as it is to use Machine Builder and then use that same machine you just created in a setup that you've programmed today, yesterday, 10 months ago, doesn't matter. You can use it on any of those setups. So, questions?
Well, before questions, mate, that was absolutely brilliant. So we've just got someone said outstanding, man. So yeah, mate, really thank you so much for coming on and doing this. Thanks for spending your time. People are really appreciating you giving this a good run through. I mean, that was 50 minutes of pure excellence. So thanks for that. One thing that I just want to bring up this on the chat is a really good point that someone else made is, for example, we use a Lang system at our technology center. So we have base plates that never leave the machine. That's a really, like, include that in your machine model.
100%,
yeah.
Include that in your machine model. Brilliant.
Yes, that's a really good point as well, made. So then you can put that joint origin that Kieran mentioned. You can put that joint origin in the base plate, however it locates, and then you can bring the vices and stuff in there. So that was a really good point. Just want to touch on that again.
Absolutely.
But yeah, I don't think we've got quite. I think people are just.
I've actually got one more thing to show you actually, because this is something just recently come in. And I don't know if it's going to work, but I'd love to just try and show you guys if we can.
Definitely. I'm all up for trying new things.
So bear with me. Let's go into the sync up data machine, and let's just tell you what, let's just close this down for now. And let's jump into, and I'll tell you what, let's just close this down for now. And let's just jump into our machine library, and let's just go and have a look at that machine we've just created. And let's jump into, okay, so good, we're in the right place. Now, one thing which some of the XD and CXD teams have been working on is trying to help people use the machine builder to learn how to use it. So from the question mark on top, help, it says show learning panel. Now, in here at the moment, what it should say is hopefully if we select a machine, we should be able to, I'm hoping, there should be some interactive learning at the moment. There was. Let's just see if this works. Don't know why it's not working at the moment. Probably because don't know. What's happened is a lot of the content that's been put together, contains GIFs, images, a whole lot of different things. I'll tell you what. I'm just going to exit this and let's just see if we can go into the machine builder on its own and see if we can find it.
Yeah, and while Kieran's looking at that, I'll post 2 links in the description of this after this live stream to 2 separate tutorials that Kieran's done on both simulation and the machine builder. So they're really good tutorials that he's done, bite-sized ones. But yeah, so everyone, Kieran's just finishing off here. This is the time to get your questions in. Do it now or you're not going to get them answered, basically. So make sure you put your questions in now and we'll answer them when we can. But mate, yep, people are absolutely loving this content. Lots of great explanation. Thanks a lot. Awesome guys. Thanks. Yep. So people really appreciate this content.
Well, guys, I'm sorry I couldn't get that working, but basically I've seen it before where it's got a whole lot of GIFs and images that work really well guiding you through the process. So I'll have a look into that, but it's certainly going to help you in the future on getting machine simulation and machine builder working. But yeah, again, thanks for everyone for coming on. Really appreciate it. I'm glad I could help people kind of just understand some of the reasoning we went about, including the post, for example, the machine simulation post, and why there's no output, and why you want to post out first, get that warning, check that your machine's updated, your post is updated to be machine sim ready. And when you do want to use the machine simulation ready post, you know what you're doing. There's the kinematics file you need to go and check. Be aware that the output you're getting is going to be different if you're using a machine sim ready post, because it's drawing on that machine kinematics file to not only drive machine simulation, but also drive the NC code at the back end as well. So just important things to remember. But yeah, guys, thanks very much for all your time, and drop us feedback via the forum, via all of the social media channels. And thank you very much for all of your time. Really appreciate it.
Yeah, but we've got a few questions. First of all, Mr. Coffee Paul, really appreciate all the comments. Thanks very much for the support. It is much appreciated. I'll let Kieran know that afterwards. A couple of questions that have come in. If my default 3-axis machine X is going from front to back rather from left to right, how do I correct that? Just so I think I'm reading this correct. I think what you're saying is your actual machine uses X front to back. Normally machines are X left to right. So what you've had to go to is have to go into your machine builder and change the way that X and Y are defined. And then you'd have to go into the kinematics file and just make sure that's all set up right on there. So yeah, so
absolutely. So in the machine builder, you'll see there's a little icon called Move Components. Now here you can move or rotate the machine into the correct coordinate system if it hasn't already been done so in the design environment. So we've got this little tool in here, and I did skip over this, but it's a critical component to actually comment on. You're right. If you do find, one of the things actually to bear in mind with machine simulation is you don't need the home position or the datum to be in the center of the table for the machine. The only thing that really machine simulation requires is that the z-axis and the major orthogonal axes are going in the correct locations. So even if your machine is even if your triad's in one location and your machine's over here, providing your z's going in the right direction, then you can continue with that rather than having your two kind of lined up perfectly on the table. So there is leeway for that.
Definitely. So all you'd have to do in that is go in your kinematics file, probably change the chain, because maybe now that your Y is dependent on your X rather than whichever way it needs to be, you need to look at that, and then you need to, when you select the components, make sure you select it. So all that's happened there is the default file we provided maybe doesn't quite show what your machine is, but hopefully Kieran has shown you the tools and how to actually use those and make that fit.
Play around with the kinematics, click on OK, go to the jogging button and jog them, see what happens. And that way you never have to leave the machine builder. You can always stay in the machine builder, play around, tweak, and then when you're good to go, you can hit the save button. So yeah, absolutely.
Yeah, brilliant. Again, thanks everyone. We really appreciate your time. That was nearly an hour of, again, really good content. So thanks, Kieran. Thanks, everyone. Let us know in the comments below, what do you think about machine simulation? Any questions? I'll be watching this for like a week going forward, so I'll try and keep things on top of there. If you like these videos, give it a like, maybe subscribe, hit the bell if you want the notifications. You know the drill. Brilliant. So that's us for tonight. We've now a well-deserved drink in the garden while we've got a bit of British sun. And catch you all again soon.
Thank you very much, everyone. Take care of yourselves. Bye.